Welcome, and today we are going to turn this Mac into the most powerful Mac ever. So join me. We'll see how it goes.
All right, hold up. Time out. Okay, just 1 second. Hear me out. This guy doesn't know what he's talking about. Okay, it was filmed years ago, literally years ago, before Apple's M1 ARM architecture stuff. Okay, so this is like we're talking Intel to Intel back in the day. It's 2024 now. I'm re-editing finally these videos, but he doesn't know at all what he's saying. Okay, so just bear with me for that. All right, we know now this isn't actually the most powerful Mac in the world, but at the time we had some high aspirations based on the numbers of how much memory, how many cores, those sorts of things. Okay, so this guy here, although he looks young and a little naive, now we know a lot more. All right, so just bear with us. The build's still fun. Hope you enjoy it, but yeah, it's some of the claims may not add up as much as they want. So it's just like you can keep going, all right, but just okay, cool.
So how are we going to turn that old Mac Cube into the most powerful Mac ever? We're going to use 4 of these. These are the LP179s. They come with Intel Tiger Lake UP3 processors, 32 gigs of RAM, and a terabyte hard drive. Using 4 of them, that gives us 32 cores, 128 gigs of RAM, and 4 terabytes of storage. We also get some nice ports for dual network cards, which are both 2.5 gigabits, and HDMI and some USB. Plenty of other pins on here we might use later, but let's go ahead and check it out. There are still a lot of things I have to figure out with this build. I don't know exactly how I'm going to power everything, get network in there, and then just how to place them all together. So I probably need some 3D printed parts, a couple custom brackets. One of my favorite parts about this computer is how wonderfully designed the internal is. So Apple took this cube and they put their ports on the bottom with a little gap here for your cables. They also added this wonderful little handle that makes the inside come out. And it's all self-contained in this cage. So as you can see, the motherboard there with memory, hard drive over here, the other side with the CD-ROMs behind this cage. So this gives us a wonderful place to put all the components we need to run our Kubernetes cluster. And you can see the inside is just a hollow shell with these clamps so that it fits in there. And just for reference, here is one of our boards with the rest of the case. So we should be able to fit them, hopefully 4 of them, pretty easily inside.
All right, so here's the main teardown that I did for the cube. I went very carefully through this whole thing because I needed to make sure that I could actually put it back together or at least reuse some parts of it. And so all of the components I did donate to people on Vintage Apple on Reddit. Many people had cubes that were partially working or needed parts. This main core turned out to be pretty crucial to the whole design. This is how the handle worked, and it held the parts so I could use it. I also wanted to tear down the main plexiglass part of it because I need to take the logo out of it to replace it and drill some holes. So it was really fun just getting to that point, and now I needed to start building things once I had all the parts out and I understood a little more how it worked. The first thing I was going to do was 3D print this internal bracket. Basically that's that core piece that was a heatsink, because the original design was all fanless. That core heatsink was crucial to the integrity of the internal parts. So I needed to make something that would fit in there and keep those handles in place, but also I was going to use it for some other components, like part is like maybe putting a switch in there and doing some other things that I knew that I would probably want if I had space for it. Again, at this point, I'm just designing the basics and trying to get it back to some place of I have an empty cage that I can start with. And so I probably went through, I don't know, 10, 15 designs of this center core. Many of them worked fine. Some of them, the holes were too small. They were offsets. But a lot of different things, just reprinting it and then figuring out how to get it to work. Before I go too far into this build process, I'm just going to apologize for the video quality of this. Almost all of this video was taken from TikTok live streams that I did. I built pretty much the entire thing on TikTok Live in vertical video formats, and now I'm zooming in and making it work here for YouTube long form videos. So I learned my lesson. I'm going to do just standard widescreen video in the future, but for now, for this video, this is what we did. So this video is broken up into some main components depending on what I was building at the time. So I found the pieces of videos that I had. Sometimes they're repeated because I recorded small clips here and there as I was doing live streams and recapping things and showing different parts of where I was in progress. So hopefully I put it in a coherent order that you can follow. This was one of my early versions of it. Again, I needed some things that you'll see later in the video about how we adjusted it to make it a little more functional. Right now, I just stripped everything out of the cube and I wanted it to fit here back inside. And I also kind of knew that there was a place I could mount this fan at the bottom, or at least the bottom in this case when it's in the cube. If I pull it out, it'd be upside down, but I knew I could use that to kind of spread some air over the computers. And of course here, the holes were a little too small printed, and instead of redesigning and reprinting, let's just make sure it works before we readjust that and print it again. So we finally have a center core that the handles should work, and I can put it in and out without needing to do anything drastic. This is now designing the holder for the compute itself. I wanted this bracket that's going to fit on either side because I decided that was my best bet for fitting all 4 machines. And I always just start with cardboard. Cardboard's free, basically. It's super, it's cheap to kind of mess up, and it gives me a basic idea of what I want. So here I am just marking out some of the mount points for the systems. I'm not being super precise here because we're going to see how it works and then remeasure and then design a piece for it later. And in this case, I just want to make sure that these standoffs will be tall enough that the computer will actually fit inside of the cube because I don't actually know the clearance that I need for putting the system in and out of the cage. I can't tell what the clearance is while it's inside the cube because there are some pieces in there that kind of stick out and I can't see them from the outside. So it was a little hard to get to. So in this case, we're just designing that first template, and we're going to take this template and make it as minimal and sturdy as possible. And so in this case, I'm just designing what I thought would probably be structurally sound-esque to be able to hold the systems in place, but also allow airflow from that fan that's going to be on the bottom, because I'm mounting it with those heat sinks facing the fan, and so you'll be able to have air blowing over the heat sinks without blocking just where they're actually trying to blow. I made an SVG out of that template and brought it over to a friend who had a laser printer, and then we made some acrylic plates that we were able to put in there.
So the plate gets mounted here. I have these standoffs that were already on the part of the case, and so the acrylic mounts there, and a cutout for the fans. It's all clear, so it's a little hard to see, but it's in just like that, and then the computers mount to it with the heat sinks over the fan here. So I'll have 2 banks of computers on either side of the fan.
And now here's just some footage for me actually doing the test fit. Again, I have to take the cage apart every time I want to do anything to it.
All right, I'm making plates for the computers to mount on, and so far I got one of them set. So the computers have standoffs here. It's actually on an acrylic plate with a hole back here for the heatsink, and I just got standoffs here that it mounts to. And so this plate gets mounted on the inside of the case. Here's the second one I'm working on. I actually need to drill out the holes a little bit. And that mounts right here, wherever I put it, right here. So this fan goes on the bottom, blows the air up. The heat sink is on the back side of this, so both heat sinks for the fans face the fan inside. They also have their own fans on them. But one of the problems I had was this is just, it was first originally just a separator to keep these pieces apart. It has these little brackets here, or bumps that I was mounting this to. Yeah, there was a blue part here, but it didn't have these mount screws, and it didn't have these fins on the bottom. So the mount screws are actually for a network switch that mounts
right here. So I have a network switch that's mounting in the middle of the entire enclosure. And then I have cables that are coming up to actually plug into the computers themselves. And the fins on the bottom are above this fan, but it actually, if I push it down a little bit, and it holds these down. Because if I don't hold them down, I can't push the release mechanism. So I need to be able to push it down to get this release mechanism to come up. So it clicks when it goes down. If it's not pushed against the case, and so I didn't have anything mounting it before.
This is kind of the second phase. I had this light panel that I wanted to use that was programmable. It has a little microcontroller on the back side of it that uses MicroPython, and I knew I wanted to mount this inside the case as well. So I'm using this CD-ROM mount that was part of the case, and I'm going to actually mount that where the CD-ROM would have been because there was a little extra room on the case on that side, so I could fit the display and the computers behind it. So you won't see the computers from on this side; they'll just be behind this panel. There's me just doing a quick test fit to see is there still enough room there, because this is all still kind of questionable. But I need to figure out how to cut this mounting plate to make sure that I can mount the light panel to it and mount it there, screw it in, and then also get the microcontroller, which plugs directly into the back. So I just went straight at the case with a couple standoffs to be able to mount it. It wasn't, I was a little worried I was gonna mess it up, but also not too worried because the mount itself was pretty straightforward. And if I did mess something up, I probably could make another one that would work. It does have screws on the top and bottom that hold it in place, which is really nice because it held it nice and sturdy. So the integrity of the mount itself didn't matter as much because the LED panel was structurally sound as well. And then there's that microcontroller that goes on the back, and I had to cut out a piece of that mount so that it could fit there without actually touching anything and allow it to fit without the computers. Here's a test fit of that LED panel in place. This is kind of the first time I was putting that in place to make sure and seeing where it was rubbing, just because I needed to make sure that it would fit and slide in and out. And then here's actually the compute on the plexiglass, because there were parts of the mount that were hitting the computers. I couldn't fit it all the way in. So you can see here, like those bottom USB on both computers, I need to cut that out a little bit more. Once I mount it, I can mark it and then cut those out so that the plate will slide back closer to the computers. And here's another test fit with that plate mounted and compute in it. It's a little bit stiff. I got to figure out why it's not sliding all the way, but this is kind of the first time that I have the main components in place that I know is like, okay, how much weight is this going to be? Do these plates work? Is the fan working? And does the handle still work? I did put it in the case a couple times, and I was not sure if I was going to be able to open it again, and I didn't quite know how to get it out. So there's just a static shot where I cut out from that other plates.
Here's the front of the case. Here's the logo on the front. Now, I need to run power to it. I have a light that goes on the inside here. It's a little ring light. It's powered by a AT85. So it fits everything fits inside of this ring except for power. And so I need to run power to it. And I already have a hole in the case that I drilled, expecting myself to say, oh yeah, I can run power through that. But this slides here and fits inside. And then this goes on the front. However, I drill the hole through here for power. I can drill a hole through the metal exclosure to run the power all the way through. But my problem is, I'm going to run power all the way. I was planning on running power back to one of the computers so that when the system powers up, when the computer's powered on, that's when the logo lights up. But the whole computer case comes out. And so these need to disconnect somehow.
I decided that some pogo pins on top of the case where the power button goes is probably my best bet, because the power button has a little more space because I pulled out the old power button. I'm going to have a different switch. And so I'm modeling a couple different brackets. One of these is going where the power button is on the case itself, and the other one is going on the internal cube components to mount two different sets of pogo pins because I have lights on the front for that logo. I also have lights on the back for just some like bars that get mounted on the back. And so in this case, I don't know how many iterations of this I went through, but it was a pretty small print, so it was okay just to kind of print it a couple times. It didn't take too long. A lot of it just had to deal with aligning these pogo pins because I needed them to reliably connect to each other. And they are magnetic, but the magnets they're small, and how the cases align is really what's determining if those pogo pins are going to touch or not. And so in this case, I'm doing some test fits. I'm going to just glue those in place to figure out, okay, is this actually going to work the way I expect it will? This plate right here is the internal cube. It's the top of the internal cube. So that's the pogo pins that are going to plug in there. We're going to screw those on, and then we're going to screw the other ones onto the outer cube portion. And we just need to check, like, are they aligned? And I was able to give myself a little bit of wiggle room by making those mounting screws just a little bit looser than they needed to be, so that the pins could move a little bit. But again, I don't have a lot of wiggle room here. The pogo pins are almost as wide as that button is. So here I'm just checking, connectivity. Are these aligning, and do all 8 of them align? Because each of the ports, although they're only using 2 pins for power, I still want to make sure that they do get aligned when I plug them in. So that's replacing the power button. Again, pogo pins. If you saw during the teardown, there's like this big piece of plastic that goes on top of it. It's not all like one solid piece, so the plastic kind of hides some of these pogo pins and some of the wires that come through. So it's not a big deal if I have the pogo pin stick up a little bit. I'm using some thin wires on top to make sure that we're going to be able to run some wires through it. Here's that internal light for the logo. It's just a capacitor with a little microcontroller. I programmed it up with a little bit of C code that actually was an example for this light. It does this spinning logo for a little while, and then actually goes to like kind of the Mac breathing logo. So it kind of does that while it's booting. It does the spin, and then it switches back to a breathe.
All right, so here's what I ended up with for the pogo pins. One set of pogo pins is just driven off the USB of this board, and it's just power, no data necessary, because that powers the chip that's in here. And so all it's doing is sending power to 2 of these pogo pins, which when it plugs into the board, into the case, goes here to those pogo pins at the bottom. Those pogo pins have a wire that go actually across the top. You can't see it though because there's a cover on the top here. So they actually go from this power cord, they go around this vent, and then they go into the CD-ROM drive. And then out of the CD-ROM drive, I drilled a little hole in the metal case, and that goes right into the back of this. And so that's where I soldered it in to power this. So as soon as these pogo pins make contact, it powers this on. The other pogo pins are right here, and there's 3 of them actually that get power. So it's onto this Pi Pico, and this Pi Pico has 2 of the data lines that actually send a signal for the LEDs and also power. So those are going to the other pogo pins. Those are reaching the other one in here, and that reaches from the power supply here onto these LEDs. And so it goes from top all the way down to bottom, and then over, back up, back over, and then back up. And so these are all one big series of LEDs powered by the same Pi Pico, but it's the same pogo pins that feed through there off this Pi Pico, give it power. And that Pi Pico is getting USB power from one of the boards as well. So I can program the Pi Pico off of this USB, and then that feeds the lights.
You gotta get these inside of a case somehow. You don't want them just sticking out by themselves. That the old power supply was in for this case I'm reusing, but it doesn't really go over. I was thinking about just cutting this in half and then just kind of sticking it over, but it's also not tall enough. So they're like a big bundle of cables just sticking out the top, and I don't think that's going to look so good, especially when I need to mount power to it somewhere. So I'm trying to measure this and then make a 3D case that looks something like this, but it's taller. So actually, I just might make a big box that fits over it, that has thick enough walls to hold the entire thing, because the original was real flimsy. Once it's all, I mean, I guess once it's together, it's pretty sturdy, but the walls themselves are pretty thin. And then I do want something with the vent holes here. I'll have one on each side to make sure the heat gets out, because I don't want to worry about this thing overheating.
I ended up designing a big box. We just decided the simplest thing. This is one of the test prints. I just want to make sure it was big enough and tall enough. And also I need to have cables on the sides, so I have a little extra space around it. But I'm mounting these switches in here that I'm going to wire in. They're going to plug into those power supplies. This test fit, actually, those buttons are too close, so I know I have to reprint it anyway. We got those logos where the fans are going to go, and the fans are on either side of the case, so they're both, blowing outward. And I'm going to have a cap that sticks on the top here, which covers all of these top cables. This is the power brick I ended up with. So we see here that I have a single cable that actually splits into a Y here. So both of the power supply units are being plugged into the same outlets, but gives me 2 inputs here. I can turn on both of them individually. They both share load between the computers, but one of them has like the network switch and some lights on it, and the other one has like the fan with some compute. So I share like the accessories between the two, but they split half and half between the actual computes. And then I have the vent here on both sides where that logo is. I have a hole that I drilled here so I can switch the 110 volts for the United States, and then when I travel overseas, I can flip them to overseas voltage. Because the power supplies do both. I added just a couple vents here. I need to add a lot more vents to this case because the fans do kick on pretty loud when it's going. Otherwise, the case they screw in here into the power supplies that are inside of it to kind of hold it all together. The bundle of cables coming out, you can see here I bought these 12 plug adapters on Amazon, and this is an extension cord, so when I have longer runs, if I'm on a stage or something, I plug this in. But in general, it just plugs directly into the box with one adapter here. Inside of these power cords is just PC power cords that I cut in half. There's 4 of them that I trim because each one has a positive, a negative, and a ground, and so I just cut the ends off both, and then on one side I put it into the power adapters directly. On the other side, I just put here into the plug. So that's the whole power supply. It's just the 2 3D printer power supplies and the case. One of the nice side effects of this power supply and running the LED panels off of USB from the machines is right when I turn on this power supply, the USB gets power even though the machines themselves don't get power. So the panel lights up, the fan turns on, and the switch turns on without the machines actually turning on. So when I want to power on the machines, I have these 4 buttons in the back here, and I have labels on the side here, so I know that this one is give you, this one is never, this one over here is gonna, and this one's up. And then I label those back here. I wish I would have wired them in order, and I just didn't, but it's up, give you, gonna, never. And so I can turn on each one of the machines individually, and they do have a light on them that lights up here that's just soldered onto the jumpers. So I can see those when it's actually powered on, but otherwise I can control which machines I turn on individually, as well as turning on the light panel, switch, and fan before those machines turn on. Alright, thanks for watching. That's the whole builds and pretty much all the major steps I had to go through to build it. The box has traveled around the world with me. It's gone to Dubai and many other states in the United States. I've brought it to conferences and meetups, and it's been working really well. The mechanism, the handle is still holding up. I did have to rebuild the internals once just because we shipped the box from Chicago to LA, and I didn't actually know how to internally pack some of the system so that they wouldn't break. So the plexiglass shattered by the time I got home. So we recut some plexiglass plates. I rebuilt the internals of it, and everything's been working since. There's plenty of other small problems that I came up along the way. Things like the boards were mounted too high on the plates when I first put them in there. I needed to get special ordered Ethernet jacks that had really low profile so they'd fit on the sides. And then various other small things that have happened while I was building it. But this was the main build process. Those were the components that I really struggled with creating something and figuring out that I wanted to share. So thanks so much for watching. If you have any questions, please leave it in the comments, and we'll see you again soon.